Today, we are decoding Morse code, counting the number of 1 bits in the binary representation of an integer, and then we are dealing with anagrams. Hello world, and this is Versus Code Wars. We begin today with this morning's warm-up segment. 4 easy katas to prepare for the difficult katas coming up later in the episode. We begin with a function that, given a number, returns its opposite. Let's go ahead and get started with this. Our function signature is going to look like this. Const opposite. It takes a number as a parameter. Here's a little fun fact. If you're using arrow functions with a single line return value, what you can do is something like this. This single line indicates that we're just returning this number that we passed in here with the unary negative operator here to turn it into a negative number. Let's go ahead and punch this into Codewars here and try this out. And we are good on that one. The next one, we are removing the first and last character from a string. Let's go ahead and get started with this one here. Our function signature is called remove char. And it takes a string as an argument. And this string will simply return, I think it's str.slice. Start from index 1 to -1, I think. Let's give this, let's run a test on that actually here. Console.log remove char eloquent. Let's punch that in the node and see what that looks like here. Ignore that. Node warm up char filter. Now, as you can see, we get our string back with the first and last character therein removed. Let's go ahead and punch this solution into Codewars here. Attempt to test, and we are good on that one. Our third warm-up kata of the morning is called Exes and Ohs. Our goal here is to check to see if the string has the same amount of X's and O's. The method returns a Boolean, and the strings can be case insensitive. Let's go ahead and give this one a try. Our signature is const xo equals, and it takes a string as an argument. Alright, what we can go ahead and try doing here is I think we'll do something like this. Const letter count equals str.reduce. We'll have an accumulator here, and what we need to do first is split the string into its individual characters. Then hit reduce. Take an accumulator and a value, in this case our char. And for the initial accumulator, we'll have an object with 2 properties, x and y. The values of each of these keys set to 0. What we also need to do with this string is we need to convert this to lowercase. I'm going to say what we have so far here. And what we'll go ahead and do is if char is equal to x or char is equal to o, we will go ahead and run at key char ++. And then at the end of that, we'll go ahead and do this. Return letter count.x equal to letter count.y. So what we're doing here, we're taking the string passed into this kata function, converting it into lowercase, splitting it into its individual characters using a blank string separator. then running the resulting array through the reduce method. In its predicate function, we have our accumulator here, which is initially set to an object with the keys x and y, each set to 0. In the predicate function, we take the current, check to see if the current character is equal to a lowercase x or a lowercase o. And if either of those are true, we take that respective character in this object here and increment it. Alright, we then take this resulting object, we compare the values of properties x and y, and we return true in this function if those two values are the same. Let's go ahead and punch this into Codewars and see what this looks like. Run the tests. And we have a problem. Cannot read property O of undefined. That's because it's not Y, it's O. Now let's try that again. Cartesian coordinates. Let's try that again. Still problems. Cannot read property O of undefined. Yep. And we're still checking Y and not O. My whoops. Still problems. Cannot read property O of undefined. Excuse me? Alright, what's going on here? Alright, let's try putting these in, setting these keys to actual strings. Let's try logging the accumulator. Ah, that would be why. In the predicate function of the reduce method, if you're not doing anything with the accumulator, you have to somehow return that accumulator at the end, otherwise you get undefined instead. Alright, let's try that. And we are good. Alright, our last warm-up kata, we are taking a list of non-negative integers and strings and returning a new array with the strings filtered out. Let's go ahead and give this one a go. Our function signature is filter underscore list. It takes an array as an argument here. What we can go ahead and do is we'll take our list here and run the filter method. Taking our element in the predicate function here, we want this method to filter out anything in this list that is not a number. Ergo, all the strings filtered out. And we can do that by doing this. Type of element equals number. Alright, let's punch this into Codewars and see what that looks like. Alright, we run this list through the filter method. In the predicate function, we take the current element being worked on, and we filter it out if type of the element is not equal to number. Let's go ahead and submit this. And we are good. That concludes this morning's warm-up segment. Let's go on to the next kata. Given a string of Morse code, the goal of this kata is to decode that Morse code into a human-readable string. Now, in this kata solution, there is a table preloaded which maps each Morse code entity into its respective human-readable letter or number. As such, we have such a table right here as well. Alright, let's go ahead and get started with this. What I think we'll go ahead and do is we're going to try using the replace method here. So we're going to do return Morse code, not replace, and we're going to use a regular expression here. This regular expression will catch our Morse code entities or the space separator right here. Actually, this regular expression will capture either our Morse code entities, single blank spaces, or this 3 blank space right here, which will represent a space in our human readable string. What we'll do here is we'll go ahead and capture either any one of the following sequences of dashes and dots, a single instance of our space, or a group of 3 spaces. Alright, we're going to take each of our matches and run this through this predicate function right here. Let's go ahead and console.log each of our matches. Now, as you can see in this test call here, we have a string of Morse code which translates into "Hey Jude." Let's go ahead and punch this into Node and see what that looks like. Node Morse code. As you can see, each of our Morse code entities, the space is separating them, and the 3 spaces right here should be captured. Let's go ahead and do a template string here so we can see how many spaces are being captured. I have another idea. In this regular expression, let's actually try a range from 1 to 3. That way it captures our single spaces and this 3 space right here. Alright, what we'll go ahead and do is we want to replace our single spaces matches with a blank string. We want to replace our 3 space matches with a single space. Whoops, this needs to be else if. Otherwise, we'll go ahead and take this match, run it through our Morse code table up here, and try to get that match's respective human-readable letter or number. When we do it like this, return Morse code, and in our brackets, we pass in our match. Alright, let's run this through Node and see what that looks like. And we have our human-readable string, "Hey Jude." Now, this kata expects this return value to be in uppercase, so we'll go ahead and take the resulting string and to uppercase. Alright, let's go ahead and run this through Codewars and see what that looks like. Now, there's no need to copy the table up here into the kata because that table's already preloaded in the kata solution. Let's go ahead and punch this into Codewars here. Run the tests. And submit it. And we have a problem. Oh, that's interesting. Alright, let's go ahead and console.log our Morse code here and see where we're going wrong. Let's hit attempt again. Oh, wait a minute. Okay, extra spaces before or after the code have no meaning and should be ignored. Alright, with that in mind, let's go ahead and run this through trim up here. Alright, let's go ahead and reflect that in our Kata here. Trim. Run the tests and try submitting now. And we are good. During one of my Kata reflections on a previous episode of Versus Codewars, I was talking about quantifiers in regular expressions. Among them, ranged quantifiers, where if you had two numbers separated by a comma inside curly braces inside that regular expression would look for and match any number of instances of a certain character class between those two numbers inclusively. You saw that in use with the regular expression in today's Kata, when I was looking for anywhere between 1 and 3 instances of the space character class in a Morse code string. Finding one space would indicate a separator between two Morse code entities, and finding 3 spaces would indicate that there was a space in that Morse code sequence. Given a positive integer, the goal of this Kata is to calculate the number of bits in that integer's binary representation that are set to 1. Let's go ahead and get started here. What I think we'll go ahead and try is we're going to do integer .toString. To convert that integer into a string, we instead convert the integer's binary representation into a string by passing in 16 as the radix, 2 as the radix, as binary is base 2. Let's go ahead and console.log that and see what that looks like. Integer.toString, passing in base 2. Alright, let's go ahead and grab one of our test strings here. We'll go ahead and do console.log, count bits. Let's pass in 10. Alright, let's feed that in a node and see what that looks like. And we have the binary representation 1010. Yep. And that turns out to be 10. Alright, what we'll go ahead and do from here, we'll do integer.toString, passing in base 2. We're going to go ahead and split that into its individual characters with a blank string separator. What we'll go ahead and do from here is we're going to filter out any bit that is not set to 1. And then we'll go ahead and return the length of the resulting array. And we should have 2 here. Alright, let's go ahead and punch this into Codewars and see what that looks like. Run the tests. And we are good. When using the number object's toString method, be sure to take advantage of the toString method's lone parameter, which is the base representation you want the number converted to when you convert it into the string representation. For example, if you pass in 2, like I did in the Kata solution here, you would get the number back in a binary representation. Try other radixes too and you'll get some fun results. For example, pass in 8 to get the octal representation of the number, pass in 10, which I believe is the default argument for the radix parameter, to get the decimal representation, or pass in 16 to get its hexadecimal representation. An anagram is a pair of words such that the words contain the same letters and numbers thereof. Given a word, x, and an array of words, y, the goal of this Kata function is to return an array of the words in y, which are anagrams of the initial word x. Let's go ahead and give this a try here. We first need a helper function to determine if two words are anagrams of each other. Let's go ahead and do that first. Const is anagram equals first and second are two words. And what we'll go ahead and do is, I think string has the sort method, right? First.sort? No. What we'll go ahead and do is, we'll split the two words into their individual characters. What we'll do is, const first chars equals first.split sort join. What this does is split the string into its individual characters, sorts them based, I think, on their ASCII values, and then joins the sorted array back together. We'll do the same with const second chars second.split sort join, and we'll return whether first chars equals second chars. I don't think chars would be an accurate name for that. Let's try sorted. And I just want to have a look at some here first. Words.map. W is anagram word W. See what that looks like here. Let's feed this into node here. Undefined. Yep, we actually need to return that. So we can console.log it down here. True, false, true, false. And that's actually what we want. So, what we need to do, we need to filter out any word in our words array that is not an anagram with word. So what we'll go ahead and do is words.filter. We'll call it W so we don't confuse it with our word parameter up here. We return true if is anagram. Word and passing in word and W is equal to true. Evaluates out to true. Let's go ahead and run that through Node and see what that looks like. And we do in fact see our anagrams right here. Let's go ahead and feed this into Codewars and see what that looks like. Unfortunately, since there are no tests available here, what we'll only be able to do is hit attempt and run that through those tests here, and we are good. When sorting an array of numbers using the sort method with no predicate function, the method's default behavior is to sort the numbers in ascending order, so you get 0, 1, 2, 3, and so on. Try sorting an array of characters with the sort method with no predicate function. Its default behavior would be instead to sort the characters in alphabetical order, starting with the uppercase characters and then the lowercase characters. Try sorting many objects in an array, strings, numbers, what have you, with the sort method with no predicate function, and see what kind of fun results you can get. And that will do it for today's episode of Versus Codewars. If you liked the video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.